In this video, I will be going over Module 11.2, and I'm going over Explain 1, which is on page 545. So Explain 1 is called Simplifying Rational Exponent Expressions, and rational exponents have the same properties as integer exponents. So as we go through these, I'm going to be relating them to integer exponents, which you should have already learned. So integer exponents, if we think about this as like x squared times x cubed, we would add those exponents and we would get x to the fifth. So the same thing can be said for when it is a rational exponent. So here I have 12 to the 1/2 times 12 to the 3/2. So I'm going to add those exponents and get 4 over 2, which is 2. 12 squared is 144. So product of a power property, we add the exponents. So the next one, if we had x cubed divided by x squared, we would say there's 3 x's on top and 2 x's on bottom, and 2 of them will cancel, which is subtracting the exponent. So x cubed minus 2 would be x to the first power. We'd subtract those exponents. So we're going to do the same thing here. 125 to the power of 2/3 divided by 125 to the power of 1/3 is 125 to the power of 2/3 minus 1/3, which is 1/3. And 1/3 exponent is the same thing as the cube root of 125, which is 5. So for quotient of powers property, we subtract the exponents. For this next one, if we had x squared to the power of 3, we would multiply those exponents and we would get x to the power of 6. So we're going to do the same thing here. 8 to the power of 2/3 times, all to the power of 3 means I need to multiply those exponents. And when I multiply these exponents, the denominator 3 and the 3 here reduce to 1, and so I just get 8 squared, and 8 squared is 64. So power of a power property, we multiply the exponents. For this one, let's say we had 2x to the power of 3. We would have 2x cubed, which is the same thing as distributing that exponent. So 2 to the power of 3 times x to the power of 3, or 8x cubed. So let's do that here. We have 16 times 25 all to the power of 1/2. Let's distribute that exponent to both of those. And 16 to the power of 1/2 is the square root of 16, which is 4. And the square root of 25 is 5. So when I multiply both of those, I get 20. And so for a power of a product property, we distribute the exponent. And now our last property here, if we had, let's say, 2 over x to the power of 3, we would say that's 2 over x to the power of 3, which you can distribute the exponent to both the numerator and denominator and get 2 cubed over x cubed, or 8 over x cubed. And so let's do the same thing here. We have 16 over 81 all to the power of 1/4. Let's distribute that to the numerator and the denominator. And then the 4th root of 16 is 2. And the 4th root of 81 is 3. So my answer is 2/3. So for a power of a quotient property, you distribute the exponent. So let's try these in example 1. So example 1 says simplify the expression, assume all variables are positive, and exponents in simplified form should all be positive. So here I have 25 to the power of 3/5 times 25 to the power of 7/5. I'm going to add my exponents, and I get 25 to the power of 3/5 plus 7/5, which is 10 over 5, which is 2. So 25 squared is 625. For part B, we have 8 to the power of 1/3 divided by 8 to the power of 2/3. And since they have the same base, I subtract my exponents. So here I subtract them and I get 8 to the power of negative 1/3. Now, remember, the exponents should be positive. So what do we do with a negative exponent? We bring it to the bottom and make it positive, which is the definition of a negative power. And then with a little simplification, we say 8 to the power of 1/3, or the cube root of 8 is 2. So my answer is 1/2. Flipping the page to 546, we're going to continue part B of this example. So let's take a look here. So the first thing that we want to do is we see that there's a y on top and there's a y on bottom. What can we do with those exponents? Well, that's the quotient rule. So I know that I can subtract those exponents. And so that was quotient property. And so I subtract those exponents and I get, what is that, 2, 4 minus 2 is 2, so I'm going to get y to the power of 2/3. And now I have an exponent on the outside of both of these, and so I want to take that and distribute it to both the numerator and the denominator. And when I do that, I'm going to simplify. So when I distributed this exponent to the top and the bottom, I was using power of quotient property. And to simplify that, we're going to multiply these exponents right here. That's another one of our properties. And the name for that property, let's go back and look actually. That way you know how to read this chart. So we have what kind of looks like this, right? We have y to the power of something, and then all that raised to the power of something. So that one's power of a power property. So for this one, the one that tells us to multiply is power of a power property. And let's see, let me zoom in so you can see a little bit better. The 2 and the 2 are going to reduce, and the 3 and the 3 are going to reduce. And I'm going to get, on top I'm going to get y, and on bottom, I can think about this as the square root of 16 cubed. And the square root of 16 is 4, and 4 cubed is 4 times 4 times 4, which is 64. So my answer is y over 64. So what we did was we used our different properties in order to simplify this here. And let's slide on over and check out how to do part B. So I see a product in here and I see a power out here. So what can I do with this exponent? I'm going to, sorry about that, I'm going to distribute that to both of these. So I'm going to get 27 to the power of 2/3 and x to the power of 3/4 raised to the power of 2/3. And so let's simplify this right here. I have this power to a power, so I can multiply those. And the 3 and the 3 will reduce. And 2 over 4 is 1/2. So my exponent here is 1/2. So now dealing with this right here, if I think about this as the cube root of 27, all to the power of 2, right, your denominator is your index and your numerator is either the power inside or the power outside. And 3, or the cube root of 27 is 3, and 3 squared is 9. So in front I have a 9, and then I have an x to the 1/2. So I'm going to leave your turn 3 and 4 up to you guys. If you need to, go back to the chart we created, and you should have written down these over here. These are properties that you should have seen before. Now we're just applying them to rational exponents. So good luck, guys.